The compact drive technology. These are drive controllers for different drive technologies up to 48 volt. This includes DC and stepper motors as well as BLDC and servo motors. All these drive solutions can be easily and quickly operated with the onboard tools of TwinCAT 3 and optimized to the application requirements. All drive terminals support different operating modes. On the one hand, operating with the TwinCAT NC. In this case, the NC generates the set points, either speed or position set points. If the terminal is operated in CSP mode, the controller loop for the speed controller is then closed in the drive. That means directly in the terminal. The connected feedback is then used for this function. Of course, this explains that the selection of the feedback, which means the resolution, has a high significant effect on the control quality. For simply point-to-point movements, all drive solutions support an integrated travel distance control. Here the drive controller receives all the values required for a movement from the application program via the process data. That means all necessary data for this travel command transferred to the drive controller via the process data from the application program. This includes the target position, the speed and the ramps. Drive Manager 2 provides a convenient front end for setting the parameters of the controllers. Here the control group is displayed as a block diagram for each terminal, and the control parameters can be adjusted directly. Every change to the value is automatically saved in the TwinCAT configuration. This means that the control parameters are automatically transferred after a terminal exchange. Of course, the Drive Manager can also be used to adjust all other drive relevant data, like the motor data or the feedback resolution. Further functions such as the speed pre-control or the torque pre-control and various filters allow load and application-specific optimization of the entire axis. Here is another feature of our servo terminals, the cogging compensation. Here the cogging moment of the motors is compensated by a current pre-control. The information required for this is stored in the electronic nameplate of the Beckhoff servo motors and is automatically transferred to the terminal when the motor is scanned. The compensation of the cogging torque is particularly effective at the low speeds. In this example, at 100 degrees per second, that means approximately 1.5 revolution per second. This is extremely important for interpolating axes that, for example, describe a circular path, since the effect of the cogging torque change depending on the speed. The high performance of the drive controllers in interaction with the EtherCAT drive bus system and the onboard tools of TwinCAT 3 automation software guarantee fast and effective realization of your requirements.